Hello, so today we are going to learn how to convert decimal to hexadecimal. And since we will be doing some checking as well with our answers, then we are also going to learn how to convert hexadecimal back to decimal. Before we start, we need to have some kind of review first with our number system. We have discussed already that binary. Why is it binary? Because it makes use of two digits, which is 0 and 1. And the next one, of course, denary, our comfort zone, the one that we use in our class, in our maths class. So it make use of 10 digits, and that is 0 to 9. In hexadecimal, we make use of 16 numbers. Here is how we would write hexadecimal in denary. However, if we're going to use it in hexa form, the numbers 10 will be letter A, 11 would be letter B, so it will be represented by a letters instead, and then 12 will be C, 13 as D, and then 14 E, and then 15 F. To be more efficient and faster, we have to remember the multiplication table of 16. So basically, this is a better way for you, or faster way for you to do conversions, especially if you're not using a calculator. So what I meant by remembering is that you have to memorize.
No, God! No, God, please, no! 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 No!
So I have here the table, the multiplication table of 16. Now, with that, let's put that on this side, on our left side, and we will have an example here of using this table. So let us say we have the number 78. So the reason behind why we need to memorize a table of 16 is that in order for us to convert a denary number to a hexadecimal, we need to divide it, keep on dividing it. So here we have 78, we write it here, and then we divide it by 16. So we look at the table, the one with the closest number that is not more than 78 will be 64. And that will be 16 times 4 is equals to 64. With that in mind, we are going to write the number 4 below the 78. So we have here the 4. And then we are going to subtract our the number that we would like to convert with the answer 64. So that will be 14. We'd subtract 78 by 64. Where did we get 64? It's from 16 times 4. And we write the 4 here. So with that, we can therefore write here that the answer will be 4, remainder 14. Now, 14 is less than 16, so therefore, we would stop from here. So this will be the answer, or the final answer for our conversion. However, this is denary. We have to write it in hexadecimal. Now, if you remember, we have the following equivalent values in denary to hexadecimal. We cannot write 14 to write a remainder 14 there. Instead, we will be writing E. So, therefore, our final answer would be 4E. So, 78 converted to hexadecimal would be 4E.
Yeah, boy. That's it. Lovely.
What if, for example, we're given a higher number, example of which is 361. So same procedure, we still divide it by 16. 361 divided by 16 will give us a value of 22 remainder 9. Now you could see that 22 here is still can still be divided by 16 because 22 is higher than 16. So the next step would be we are going to retain the remainder 9 over there, and we are going to continue to divide 22 by 16. So 22 divided by 16, and that will give us an answer of 1 remainder 6. So our final answer would be 361, or 361 is equals to 169 in base 16. That will be our final answer.